Hello and welcome to my YouTube channel, The Complete CSC Guide. And today I am going to tell you about Controlled Access Protocol. Okay, I am Sanskriti, and in previous class we have already done the random access protocols, and today we will start our Controlled Access Protocol. Okay, so what are the different control access protocols? These are generally needed, but we have already studied in these all things in our previous videos also, but it was not in a proper detail. Okay, so now we will study these things in a proper detail. That was about reservation, what is reservation, how polling is done, okay, and token passing. So these are basically used where to control the access. Okay, multiple access, these are under the multiple access protocols, but how we will control the access? Okay, how we are going to control the whole transmission, right? So for that particular thing, this control access protocol is needed, and these have three different phases. So let us start now. Okay, so first of all, what we will see is what is the control access protocol. So in control access, the stations consults each other to find which station has the right to send. As I have already told you, we have to control the whole transmission. So first of all, the necessary thing is that the stations, they consult among them, that each other, that which particular station had the right to send. Here each and every station will be given a right. At that particular right, whichever station is getting, that particular station can send the frame, right? So it is basically about which particular station is having the right to send first. Okay, so that the collision is reduced, the chances of collision is reduced. Now control access protocol grants permission to send only one node at a time. At a time, only one node, as I have already told you, that it will help in reducing the chances of collision. Next, to avoid collision of messages on the shared medium, right? Now a station cannot send data unless it is authorized by other stations. Other stations, the authorization will be given by the other stations, so that it will be authorized that yes, this particular station is going to send. The other stations will stop at that particular time, right? So this is the main reason why we use this controlled access protocol, right? Where each and every station, they are consulting first and then only they are going to send. Okay, so now we will discuss three named control access methods. First is reservation, where examples are cable modem, DQDB. Okay. Next is polling, where SDLC, normal response mode. SDLC we have already discussed, a whole video I have made. You can see that one. And for normal response mode. Last is token passing, that is token ring or token bus. So these are the three main methods which we will be using for our controlled access protocol, right? So these are the for controlling the access. Now these are the methods. First method is about reservation. Okay, so let's see what is reservation, right? So reservation, in the reservation method, a station needs to make a reservation before sending data. So it's like the train reservation. What do we do? First of all, we do the reservation for our particular seat. In that particular seat, no other person can take your seat. That is in the name of yours. So it is reserved for your name. Same thing here also it is done. A station, whichever station, that needs to make a reservation first of all, it have to get the reservation, okay, before sending the data, so that this particular time slot, it's for me only, where it is reserved for me, where I am going to send the data. That is the main thing. So first of all, the station have to do the reservation. Time is divided into intervals. The different time slots are divided. Each and every time slot have a particular interval. That particular interval will be used by that particular station who is getting the reservation. So this is the thing which is used here, why this term is used, that you have to first reserve your time slot. After that you can send the data, so that no other person can get your seat, that is no other person can take your time slot, that is only reserved for you. Okay, now in each interval a reservation frame precedes the data frame sent in that interval. So each and every interval, the reservation frame that is preceded to the data frame sent in that particular interval. So now you have the basic idea what is reservation. Now if there are n stations in the system, suppose in my system there are n stations, there are exactly n reservation mini slots in the reservation frame. Obviously, if I have n stations in my particular system, then there should be n mini slots, that is for the reservation frame, each and every. So obviously each and every station I have to give chance. So how many stations you have in your system, that number of reservation mini slots will be there. Each mini slot begins to a station. Each and every station will have one mini slot. When a station needs to send a frame, data frame, it makes a reservation in its own mini slot. So each and every station, when it is going to send the data, it will make a reservation of their own mini slot. Okay, the stations that have made reservation can send their data frames after the reservation frame. So stations have to make a reservation sending their data frames after the reservation frame. So one reservation frame done, then you have to make your particular reservation for a station to send the data. So basically number of stations, that will be equals to your number of reservation. Here you can see a situation with 5 stations and 5 mini slots reservation frame had been stored. Okay, so here you can see that how many reservation frames are there. So data station 1, it is having 5, again it is sending here, it is taking this slot. Data station 4, station 3, again station 1. So it is again having a particular slot. So you can see reservation frame how it is going on, and every data station is there. 1 2 3, every data station is there, and this is the reservation frame. The particular data station, it is making this particular frame, it is taken by data station 1. Again here you can see that this particular frame is taken by this data station, this one by this data station. So these mini slots are being used by each and every data station. So each and every data station will be using a mini slot in your reservation frame. It is reserved for that particular station, so that the chances of collision is minimized or it is lessened, okay, decreased. So this is basically is the whole scenario, right? Now next is our polling. So reservation, now I think you have understood. Now next is our polling. To impose order on a network of independent users and to establish one station in the network as a controller that periodically polls all other stations, which is called polling. So here we are imposing an order on a network of independent users. Here independent users are there, and we have to order on a network that these independent users how they have to establish one station in a network as a controller. One station will be a controller, and it will periodically poll all other stations. Okay, so one is the master station, it will poll the other stations. Okay, so there are two general polling policies, round robin order and your priority order. So these are the two orders by which these particular master, here you can see this is the master station, right? And these are the slave stations. So these master station, what it will do, periodically it will just poll the stations. Okay, you have to say now, you have to say, so it will do the main job. Okay, so this is the master station which will poll all other stations. They are known as the slave stations. Okay, so it will poll which will send first, it will send second, it will send third. So basically this construction is a bus construction. You can see here we have already studied. So this one is the bus construction, how this polling is done. It works with topologies in which one device is designated as a primary station and the other devices are the secondary station. Same thing, one is the master, others are the slave. Then the primary device controls the link. The primary device is the master device, it will control the link, whereas the secondary follows its instructions. Others will do what? They will follow the instructions, right? So basically what is happening here is this one, the primary device, primary station is the master station and the secondary are the slaves. Okay, so master station will be only one and slaves can be many, okay, in number. So this will, master will poll the whole, all slaves. Okay, master will be one, slaves can be many, so it will poll periodically. So primary device is your master device, remember that one. Okay, so it will control the link, whereas the secondary will follow its instructions. Instructions will be given by the primary, that's the master station. exchange of data must be made through the primary device. Obviously it will exchange the data since it is giving the order, so obviously the exchange of data will be done by the master station, that is your primary station, even though the final destination is secondary. The final destination will be the secondary devices, that is the slave devices, okay, which can be many in number. Now, select function, how the selection is done. Whenever primary has something to send, when the master has some data to send, it sends the message to each node. It will send the message to each and every node which are connected to it. It is the master, so it will send to all the slaves. Before sending the data, it creates and transmits a select SEL frame. SEL frame will be the select frame. To select, how it will select, okay, randomly it cannot select, so there is a function how to select that one, okay. So how it will select, it will first of all the sender data, that is your master one, that station have some data to send. First of all, before sending the data, it will create and transmit a frame, that will be a select frame, SEL frame. One field of it includes the address of the intended secondary. Now one field which will be the address of the secondary. There are so many other frames, other stations there, so which station I am sending, I will send it to all the nodes, but which node, that will be one particular your field which will have the address of that particular node, okay. While sending, the primary should know whether the target device is ready to receive or not. That's also a factor. The primary or the master station have to see whether the other devices, they are ready to accept, receive or not, okay. They can receive, or they are busy, or they are ready to receive. That's also a factor. So the master have to send the data, so it will first of all it will send if you have some data, it will send a select frame to all the nodes, which select frame will have a field where the address of the intended node is the present. But it have to see, it have to also keep in mind that whether the target device is ready to receive the frame or not, okay. So that is also a factor, it have to keep that also in mind. Now hence it alerts the secondary for upcoming transmission and wait for an acknowledgement of secondary station. So first, why it is sending that select frame, so that it will see that yes, it will wait for an acknowledgement, the master station, that if the acknowledgement is received, it will know yes, this particular station is not busy, it's idle, and I can send my data, send my frame. So this is the primary, that is your master station, and these are the slave stations, right? Now you can see here, first of all the select frame is sent, acknowledgement is received, then the data is sent and acknowledgement is received. Same thing, each and everywhere you have to wait for the acknowledgement. First of all, the select frame is sent. Why the select frame is sent? That whichever particular station I want to send the data, that is open for me or not, it's open to accept or not. If it is open to accept, then only I will send the data. So it will see, first it will sense that it will send a select frame. If acknowledgement is received, then yes, then it will select and send the data. So again acknowledgement will be received. Like this the whole process continues. So this is the work of the master and slave stations. Now poll function. What is the polling? When the primary is ready to receive the data, it has selected, now it is ready to receive the data. It must ask poll each device if it has anything to send. Now primary have received is select frame. Now it will ask that whether you have anything to send. So it will ask poll each device. Each and every device doesn't matters, or it's not necessary that each and every device will have something to send. So it will do what? It will poll each and every device if it has anything to send. If the secondary has data to transmit, if any secondary device which have data to transmit, it sends the data frame, then it will send the data frame to the master. Otherwise it sends a negative acknowledgement in a case, that is your negative acknowledgement means I don't have anything to say. So each and every device is there connected, it is sending the select frame, okay. Now it is polling which particular station have something to send. If any station have any data to send, it will send that particular data to the master. Otherwise it will send a negative acknowledgement, no, I don't have anything to send. Again, master have the main role. it will receive the data or it will receive an negative acknowledgement. The primary then polls the next secondary. Now the master will poll the next secondary. It had received the data for first one. Now again it will poll for the next phase. When the response is positive, a data frame. If the response is positive, a data frame will be received. The primary reads the frame and returns an acknowledgement. Now the primary, what it will do, it will receive the frame and now it will send an acknowledgement. Previously what was happening, primary was sending the same frame and it was the secondary frame which was sending the acknowledgement. Now it is next one, that is now the secondary frame is sending its data and the primary is returning the acknowledgement that yes, I have received your frame, right? Now what will happen, there are two possibilities to terminate the transmission. Now if I want to terminate the transmission, two possibilities are there. Either the secondary sends all the data. If all the data the secondary sends, then the termination will be done, the whole transmission will be terminated, or finishing with an EOT, end of transmission frame, or the primary says timer is up. So these are the basic things. So EOT means the end of transmission, all things have been sent, nothing is to send now, nothing is left. So EOT is a frame which will send and it will be stopped, the whole transmission process will be stopped. Or if a secondary sends all the frames together, then also the transmission will be stopped. And if the primary says that the time is up, then also the transmission will be stopped. So here the primary and secondary is there, the poll, it will poll and negative acknowledgement is received from station A. But when it is polling, then you will see that, okay, when it is polling again, so here you will see that the here the B station, it have some data. So after poll the data is sent and the primary will give an acknowledgement. Okay, so A doesn't have anything to send, it is sending a negative acknowledgement, but B have something to send, so it is sending the data. When the data is received, the primary is saying, okay, I have received your data, thank you. So acknowledgement is received. So there are two phases basically. First phase for select frame, when the primary is sending the stations, they are sending a acknowledgement, right, that we have received. Then it is sending the data. Now is polling. If negative is coming, that means we don't have anything to send. But if something is going to be sent by the station, it will send the data. And then what the primary will do, it will send an acknowledgement. So reverse things are going on, right? First the stations are sending acknowledgement, next the primary is sending the acknowledgement, right? So it's a two-phase communication. Now advantages, what are the advantages of this polling? Priorities can be assigned to ensure faster access from some secondary. So here the priority is there. The priority, why? Since it will the poll, so obviously it is based on priority basis it is going on to do done, because the secondary device, it is whichever secondary device is selected, if they have some data to send, so priority basis, the first of all whichever particular station, after sending the frame, the sender is going, the master is going on sending or polling. Okay, so whichever have some data to send first, it will be given priority, then next secondary device will be taken or polled. Okay, so priority can be assigned. Now so faster access will be done, since each and every thing they are not sending randomly, they are selected and given a priority, so obviously the access will be faster. Now maximum and minimum access times and data rates on the channel are predictable and fixed, that is maximum and minimum access time and data rates, okay, on the channel are predictable and they are fixed. Okay, so these access times are predictable, we can predict the access time slots are given, and obviously they are fixed for each and every station. But it also have some drawbacks. What are the drawbacks? High dependence on the reliability of the controller. Now how the controller is going to control, so the master, that is, it will highly dependent on the master. So reliability of the master is what here the dependence is based on. Okay, so it is depend on the controller, the master station. Now increase in turnaround time reduces the channel data rate. Obviously the turnaround time which is going on, so it will increase in turnaround time, it will reduce the channel data rate and the low loading and its throughput. So this will be reduced if the turnaround time increases, right? So these are the drawbacks. Done. Now next is token passing. So two things: polling, you have understood. Now what is token passing? So features: a station is authorized to send data when it receives a special frame called token. There what was doing, we were doing, it was we were polling. There reservation was done. Next, one was the master, other were the slave, so their polling was done. Here a token is there, which when received by a channel, he is the king. Okay, so he is going to send the things. So a station is authorized to send data when it receives a special frame called a token. Token will be received. Now it's also a frame. Okay, no certain written token is given, it's also a frame. Stations are arranged around a ring physically or logically. A token circulates around a ring. That a token is circulated around. Here no one is master or slave. Here the token is just going on inside, rotating inside this stations. Okay, they are in a ring pattern. We have already studied about the ring topology. So they are in a ring pattern. What is happening? The token is going on inside this particular ring. So if a station needs to send, it waits for the token. If I have to send something, I have to wait for the token. Okay, the station captures the token and sends one or more frames as long as the allocated time has not expired. So again, a time slot is reserved. Now what is happening? If I am getting the token, now I have the token until and unless the time is expired, I can send as many frames as I need. Okay, so as long as the token is with me, I can send one frame or more frames as long as the token is with me. When the time is expiring, then I have to shift the token to the next one. It releases the token to be used by the successor station. Now the successor station, whosoever is there, I have to release my token when the time is expired. So I have to wait for the token until and unless I am receiving the token. When receive the token, I can send the data. So many data, not one data, maybe one, maybe more than one, until and unless the time is expired. Time expired, I have to give the token to the next successor, right? So here you can see A, B, C, D, they all are the stations. So they are connected in a ring pattern. Now C have the token. So what C will do? C is now sending the data. When the time will expire, C have to give that token to the station number D, the successor station. Okay, so like this pattern goes on. Now the station interference is in two states. Listen state, first of all, is the listen state. Listen to the arriving bits and check the destination address to see if it has its own address or not. If yes, the frame is copied to the station, otherwise it is passed through the output port to the next station, right? So it have to listen that the arriving bits, whichever bits is arriving, and check the destination address. You have to see the destination address, if it is my address or not. The bits which have been sent, the destination address is my address or not. If my address, then the frame will be copied to the station, otherwise it will be passed to the output port to the next station. Since the destination station is not mine, the address is not mine, that means this had been not intended to send to me. So obviously I will pass it. If it is intended to send to me, the address and my address, the destination address and my address will be same. Then obviously it had been sent to me, I will copy the whole data, right? Now this is the listen state. Next is the transmit state, right? A station captures a special frame called free token and transmits its frames. So now the capturing of the frame, that is your token frame. When I am capturing the frame, I will capture it and I will start transmitting my frames. Sending station is responsible for reinserting the free token into the ring medium and for removing the transmitted frame from the medium, right? So here you can see the bits are copied to the output bits with 1 bit delay. So here the listen mode is there, input from ring, now 1 bit delay, it is doing 1 bit delay, then output to the ring, listen mode, to station and from station, which station is coming and which station is sending. So it have to see the destination address should be my own address, the station's own address, then only it can take the data frames. It can copy there, otherwise it have to send it to the next person. Now bits are inserted by the station transmit mode, so to station and from, so it is again a delay. So here it's the for the transmit mode, it's for the listen mode, and it is for the transmit mode where the token is being taken, right? It is capturing the token. Then now token passing flow chart. Start, first of all we are starting. Next, wait for the token. I am waiting for the token. Now capture the token. Now I have received the token. What will happen? Data frame to send. If data frame, I have any data frame to send? No. Then release the token and stop. But if I have any data to send, then what I will do? Send a frame. I will start sending the frames, one or more frames. Now allocated time expired, then again yes, release the token, stop. If no, then again it will see if any data to send, again it will send. So this mode, this particular mode, it will go on. This particular mode, this phase will be going on until and unless the allocated time is expired. One, if your allocated time is expired, you will come to here back. Or second is if I don't have any data to send. So this is two. So these two can be the possibilities, right? If I don't have any frame, I will stop, I will release the token, or the time frame is expired. Like this we can stop the process, okay, or I will release the token until and unless I don't have any data to send or the time is expired. You can send any number of frames until these two conditions. If no data frame to send, it's okay, you stop, you just pass the token to your successor. If time expires, then also you have to stop and release the token. So this is the token passing flow chart, how this whole procedure goes on. It's very, very easy, not so tough, okay. Now token management, how to manage the token. Now we need token management, obviously we need that one. If there is a loss of token or it is destroyed when a station fails, this can also happen. The station, if fails, then the token can be destroyed or the token is lost. We can assign priorities as which station can receive the token. Now you can assign a priority that which station can receive that new token, okay. So network topology, the way in which different system and nodes are connected and communicate with each other is determined by topology of the network. So topology can be physical or logical. Physical topology, that is physical layout of nodes, worker station or cables in the network, and logical is the way of information flows between different components. So this I have already explained to you, since it is needed in this token management. So again this network topology had been given here. So here types of logical rings which we can use here. Physical ring topology, the way that the workstations are connected to the network through the actual cables that transmit data is same as the physical structure of the network, right? So here you can see how the ring topology is going on, all are connected through a ring via different nodes. So here this is the physical ring topology, right? So these are types of logical rings. Now here all things will be done inside the ring topology only. So these are now related to what kind of ring topologies we will be using. Now here a dual ring topology is there, right? We have not studied these things previously in the topology section. Why? It is needed here that these different things are used only for this condition where ring topology is needed. So dual ring topology, a network topology in which two concentric rings connect each other on a node. Here you can see two rings, you will see here two rings are connected, right? Typically the secondary ring is in a dual ring topology is redundant. It is redundant, okay. Which one is the secondary ring? That is redundant. It is used as a backup in case of if the primary ring fails. If the primary ring fails, then only it will use as a backup, otherwise it don't have any use. So in these configurations, data moves in opposite directions around the ring. So here the data will be moving opposite in direction, right? So here it is moving here like this, and here it will be moving like this. So you can see both of them, that is opposite in direction. So both of the rings, they are opposite in direction, not in the same direction. One which is the secondary one, that is your redundant in nature. Now bus ring topology. Now here bus and ring topology, this is one of the hybrid kinds of thing, okay. So all the nodes are connected to the single cable called bus. Again here you can see the bus, the terminator is there where all the things or nodes are connected. Every workstation communicates with the other device through the bus topology, that is through this bus. A signal from the source is broadcasted and it travels to all workstations connected to bus cable, right? Now a signal from the source is broadcasted, and it is travels to all workstations that is connected to the cable, that is whole workstations that are connected to the cable. Only the intended recipient, whichever recipient it intended, that yes, this is the intended one I have to send here, whose MAC address or IP address matches, accepts it. Now as I have already told you that I have to see the destination address and my address is same or not. That means the intended person or the intended stations whose MAC address is same, matches, that can only accept the data. So if the MAC or IP address of the machine doesn't matches with the intended address, machine discards the signal. Same thing is there. Again you have to see whether the address matches or not. If matches, then it's okay, otherwise. Now, star topology. In star topology, all the components of the network are connected to the central device called hub. Here we have already studied these things, which may be a hub, a router, or a switch. So these are connecting devices, either hub, router, or switch. I will make a video on these things. Okay. Now, hub acts as a junction to connect different nodes present in star network, and at the same time it manages and controls whole of the network. It will manage and control whole network. So basically in star topology, the hub is the main controller which will control all the transmission and which will control all the other stations. So this hub or switch or a router, which is the middle controller, this is the central controller which will control all the transmission going on, right? So this is about your star topology. Now mesh topology. In mesh topology, each of the network node, computer and other devices, they are interconnected with each other. Everyone is connected with every other one. Okay, so every node not only sends its own signals but also relays data from other nodes also, since they are all interconnected between each other. Now tree topology integrates the characteristics of star and bus. They are connected by a terminator, but in between they are connected by hubs, right? So centrally connected by hubs and totally connected by this terminator, the whole line, the backbone, right? Number of star networks are connected using bus. So all the star networks which are connected within each other, they are connected by the cable, the single cable, that is your terminator, which is the bus, which is in the bus topology. So that is the tree topology. So this is the things which we have already discussed in the topology portion. Still today why I have discussed this thing, so that you can recapitulate that one, and also you will know that how this token passing will be done. So these are the all things, the reservation, polling, token passing, these all things have been successfully completed. If I think that you have understood nicely. If you have any doubt, any comments, anything, questions, you can ask me in the comment section. Any suggestions, you can give that also in the comment section. And if you have benefited from these videos of mine, then you can like, share and subscribe my channel, that is the complete CSC guide. And obviously you can share it with your friends also. If you want me to discuss any other topic regarding networking or any other topic related to computer science, you can tell me. I will discuss that in the next class or maybe the other classes. And till then, take care and goodbye. Okay.